So in this video, we're going to work on solving equations. These are linear equations here with one variable, looking at a sort of introductory algebra class. So we've got basically a bunch of problems in a worksheet. Just going to go through these and do solutions. Okay, so first one here, we've got 3x plus 4 equals 13. General strategy here is we can do the same thing to both sides, and we're trying to isolate the x. So what I see on the left is I see a 3x and a plus 4. I need to get rid of the minus 4 and just leave a 3x. So I'm going to subtract 4 from both sides, both the left-hand side of the equals and the right-hand side of the equals. So it's just sort of everything to the left of the equals and right of the equals. I'm going to do 3x plus 4 minus 4. Well, that's plus 4 and minus 4 cancel. That's 0. So I'm just left with 3x on the left. And then I write my equals here, and I have 13 minus 4. That's 9. Now, what I look at is 3x, that's 3 times x. So 3 multiplied by x. So to undo the multiply by 3, I'm going to divide by 3, but then I need to do the same thing to the other side to keep these equal. Now, as sort of fractions, these 3's cancel. I'm left with x over 1, which is really just x. And then 9 divided by 3, that's 3. So there's my answer there. You can check this if you'd like, with a check here. Is you can just plug 3 back into the original equation. So 3 times 3, here I'm putting a 3 where the x is, because our solution was x equals 3 plus 4. I need to multiply first. That's 9 plus 4. 9 plus 4, that gives me the 13. And that checks out. So we know our answer is correct. Next one. We got 3 minus 2x equals negative 7. So a very similar strategy here. I'm going to try and isolate the x. First thing I'm going to do is this 3 I want to get rid of or sort of move to the other side by subtracting 3 from both sides. Note the negative stays with the 2 for the 2x, so I get negative 2x. And we have 7 minus 3, or sorry, negative 7 minus 3, that's negative 10. Okay, so we have negative 2x equals negative 10. Now it's not just 2x, it's negative 2x. So what I'm going to do is divide both sides by negative 2, and then the negative 2's cancel. Here, and I'm just left with x on the left. Negative 10 divided by negative 2 is going to give us a positive 5. So there's our answer. And if you wanted to check this, what you could do is say 3 minus 2 times 5 for x. Let's see, that's 3 minus 2 times 5. We have to do the multiplication before the subtraction. Order of operations says 2 times 5 is 10. 3 minus 10 gives us the negative 7, which is what we were expecting. This checks out. Next one. Very similar. 2 minus 5x equals 12. I'm going to subtract the 2 from both sides. 2 minus 2 cancel. I'm left with negative 5x equals 12 minus 2 is 10. And now I want to get rid of the negative 5 to completely isolate the x. So I divide both sides by negative 5. And what I'm left with is x on the left. My negative 5's cancel. 10 divided by negative 5, that's negative 2. So there's my answer. And you can check this to make sure it's correct. I just plug a negative 2 in where I see x. So 2 minus 5 times negative 2. Okay, 2 minus 5 times negative 2. So I'm going to think 5 times 2 is 10. Really, this is then minus negative 10. And that turns into a 2 plus 10, which does give me the 12 that I was expecting. Note here, if you get used to this, 5 times 2 is 10. You see 1, 2 negatives. You can kind of skip straight to the 2 plus 10. Next question here. So this one, a little bit something new. We've got a fraction here, or denominator, x over 3. There's a couple of strategies here. One is I do things just like I did before. I subtract the 3 from both sides, and I get negative x over 3. Make that x a little nicer. Equals 5 minus 3 is 2. Now, I've got a 3 in the denominator, so what I'm going to do is multiply both sides by 3. I can multiply either in the left or right, it doesn't really matter. On the left, the 3's cancel. I get negative x equals 2 times 3 is 6. Not our answer, because we need just x. And so to get rid of the negative, you could either divide by negative 1 or multiply by negative 1. So let's like to divide by -1 just because the way it looks, I think it's a little nicer. The negatives cancel, and I'm left with x on the left. 6 divided by -1 is -6. Here. Now let's do this another way. Here, so we'll start over here. So we have -x/3 plus 3 equals 5. Something else I want to do, or often will do, is just get rid of those denominators right away. That is, change this into a whole number question. So to do that, I'm going to multiply both sides by 3 as my first step. And then this 3 will distribute. So you get 3 times -x/3. Whoops. Well, times -x/3 like that. Plus 3 times 3 equals 3 times 5 is 15. Here the 3's cancel. And we get -x plus 9 equals 15. Then I subtract a 9 from both sides to isolate the -x. Get -x equals 6. And then divide by -1 and get x equals -6. Note I got the same answer for both of these here. Either method works. Kind of basically a preference thing. Here neither one was really that much simpler than the other. And we can check. Now, we did this 2 different ways and got the same answer both ways. Makes me strongly suspect it was correct, but we can check still. Negative, the x is -6/3 plus 3. Well, negative and negative cancel. We get 6/3, so that's going to give us a positive 2 plus 3. 2 plus 3 is 5. That's what we were expecting. That checks out. So we're pretty comfortable with that answer. Okay, next one. Now this is our first one that has x's in, or an x in more than one place. So what I'm going to do generally is try and simplify both the left-hand side and the right-hand side first, sort of make them a simpler algebraic expression, and then go to work on this. Now note, the right-hand side I don't have anything to do. It's just -22. So really we only need to simplify the left-hand side for this question. So the first thing to do to simplify this, I'm going to distribute this 3. That gives me 3 times x minus 3 times 2 plus x is -22. So that's 3x minus 6. Whoops, well, 3x is 3x minus 6. But I have the 3x plus the x. That gives me 4x. So this x here, that x, it's really 1x. I'm like doing 3 plus 1 is 4. So that equals -22, or 12 for some reason. Now I'm going to try and isolate the x. So the idea of adding the x and the 3x gave me 4x, so I only have x in one spot now. And so now I'm going to add 6 to both sides, and this is very similar to some problems we were doing earlier. I get 4x equals -16, and then I divide by 4, and I get x equals -4. So there's my answer. If you wanted to check this, it sounds a little different than before. We put a -4 where this x is and where that x is. So you get 3 times -4 minus 2 plus -4. So this is 3 times, I could add -4 minus 2, or subtract, I guess. 3 times -6 plus -4. 3 times -6 is -18 plus -4. That works out to be -22, which is what we were expecting on the right-hand side. So that checks out just fine. Next one. Here we've got x's on both sides, so I have to talk about how to deal with this. So first thing I'm going to do is distribute the 3 to simplify sort of the left-hand side. Now I'm going to do 3x, and then 3 times 2 is 6. So I'm going to start to kind of skip some of those steps once I get used to them. And I just have x minus 10 on the right. Now here, what I need to do is I'm going to subtract x from both sides to move all the x's to one side. So when I do that, I'm going to get 2x, 3x minus 1x, there's a hidden 1 there again. 2x minus 10 equals -6. 2x minus 6 equals -10. Okay, I wrote it correctly instead of wrote. Note this is different than what we did on the previous question, where we had a 3x and an x. We just sort of added these together, and the reason for that is they're both on the left-hand side of this equal sign. So if two things are on the same side of the equal sign, we just sort of add or combine them. If we've got two things with variables on opposite sides of the equal sign, we have to sort of sort of subtract 1 off to move that one to the other side. Okay, now we'll continue with this. I'm going to add the 6 to both sides. I get 2x equals negative 4. And then I can divide both sides by 2, and we get x equals negative 2. Again, I can check this by doing 3 times negative 2 minus 2. Now this check's going to be a little different because I'm going to evaluate the left and evaluate the right. So this is the left-hand side. So this is 3 times negative 2 minus 2 is negative 4. 3 times negative 4 is negative 12. And then the right-hand side, we don't just have a number here. We have negative 2 minus 10. Well, that works out to be the same negative 12. So our answer checks out. Next one. Here again, we've got x's on both sides. Because I have a constant here, I might subtract the 3x from both sides right away. And then I have 8 equals negative 5x. Now, I generally don't like doing with the negatives, and I could have moved things around to avoid that, but here it seemed maybe a little bit simpler. I'm going to divide both sides by negative 5. Whoops, missed with that. Here the negative 5's cancel, and I get, let's see, this is 8 over 5 and 1 negative. That's negative 8/5 equals x. So I get that there. A lot of times I feel a lot more comfortable if I write this with the variable on the left-hand side. Somehow this just tells me that, oh, the variable equals this. Oftentimes I'll also just go from this equal line straight to here and kind of switch sides. It just feels more natural to me. Maybe I'm just used to it more. You could leave things like this as well. Whoops. Now, the check here gets a little bit trickier. I mean, it will work out, but you get 3 times negative 8/5 plus 8 on the left. So this is left-hand side. So that's negative 24/5 plus 8. Common denominator would be 5. Negative 24/5 plus 5 times 8 is 40/5. 40 minus 24 is 16/5. Well, then the right-hand side, that equals, let's see, negative 2 times negative 8/5. 2 times 8 is 16/5, and the two negatives cancel. And this does check out. So a little bit harder to check. No, makes it maybe a little bit less worth your while to do that if you're confident in what you did here, but you can still check. Next one. So here, again, we've got one with fractions. When I see the 3 and the 5, you could do some operations with fractions. My sort of preference is to multiply both sides by the common denominator here, which is 15. So I take the common denominator of all the denominators. These come multiple of all the denominators, which is just the 3 and the 5. So I'm going to do the 15. I'm going to multiply both sides of this equation by 15. And this is just to get rid of the fractions. So now what I get is 15 times 2 over 3x plus 15 times 2. That 15 distributes to both terms. Here I get 15 times 1/5 plus 15 times x, which I can write just as 15x. Now, what should happen if I pick the correct, or at least a common denominator, is this 3 should cancel out completely with the 15. So the 15 is 3 times 5. The 3's cancel, and I have 5 times 2 is 10x. 15 times 2 is 30. And this denominator should cancel as well. So 15 again is, well, we could write it as 3 times 5. On this side, the 5's cancel, and I get 3 plus 15x. So that was a first step just to get rid of the denominator so I don't have to do fraction operations. I'm going to subtract 10x from both sides, move all the x's to one side or the other. I'm going to choose to subtract a smaller x so I get a positive coefficient on the x. You don't have to do that, but it just makes me feel more comfortable with things. So I get 30 is 3 plus 15x minus 10x. 15 minus 10 is 5. And then I get the x. So now I subtract the 3. And I get 27 equals 5x. And then I divide by 5. And here's where I say I'm going to switch the sort of order. I'm going to write the x from the right on the left. that is 27 fifths. So it's always nice to rewrite this, even though I sort of have x equals 27 fifths here, but just without the 5 over 5. So it's really clear what your answer is. Now this one I'm going to kind of look at trying to simplify this to check, and it gets a little more complicated. Well, we could do this. It's debating sort of skipping it here, but let's check. So the left-hand side is 2/3 times x, which is 27 fifths, plus 2. Now, when I do the multiplication first. First thing I'm going to notice is 27 is 3 times 9. You can cancel that 3. And so I get 2 times 9 is 18 fifths plus 2. And then my common denominator is going to be 5. The 2 is going to be 10 divided by 5, or multiply 5 on top, and then there's a 1 on the bottom multiplied by 5. So I end up with 10 plus 8 is 28 fifths. So that's the left-hand side. Right-hand side, back up there, is, let's see, this is 1/5 plus x, which is 27 fifths. Well, I already have a common denominator, so that just adds to 28 fifths, and this checks out. Okay, next one. This one here, 7x minus 9 over 16 equals x. So again, I'm going to look at this denominator 16, and I'm going to try and get rid of that right away. It's going to work out pretty slick on this one. So I'm going to multiply both sides by 16. Now, when I multiply by 16 on the left, that's really a 16 over 1. And I can think of this 7x minus 9 as a factor here. And what happens here is these 16s cancel. So I get 7x minus 9 equals 16x. And my fraction denominator is gone. Now, some people will think of this really as I take the 16 and I move this to the right, but I have to sort of flip from the bottom to the top. That is, I'm sort of 16 times x there, and then I'm just left with 7x minus 9. So it's really the same thing that sort of I've been doing, but sort of the way you're thinking about it maybe is a little different. Now, I'm going to subtract the 7x from both sides. I'm left with negative 9 equals 16 minus 7 is 9x. And then I divide both sides by 9 to get the x alone. Again, I'm pulling the x from the right, kind of flipping the side just to make it feel like something I'm comfortable with. Negative 9 divided by 9 is negative 1. So I like my variable on the left. Now this one, when you get such a simple answer, it's just generally simpler to check than just like instead of the last question. So if I check, I get 7 times x is negative 1 minus 9 over 16. 7 times negative 1 is negative 7 minus 9. Should have wrote this is the left-hand side over 16. Negative 7 minus 9 is negative 16. 16. That's negative 1. Look, that's x, which should be negative 1. So that should equal the right-hand side, and this checks out. Okay. Next one. I'm going to pay to use our fractions again here. So what we're going to do is I see a 4 and a 3 as a denominator. I'm going to multiply both sides by 12 right away. And what I'm really going to do is multiply both sides by 12 over 1 times 2 times x plus 1 over 3. So now what's going to happen on the left is this 12 will be 4 times 3, and that 4 cancels. On the right, 12, I could write 4 times 3 as well. These 3's cancel, and now I have 3 times 3, that's 9 times x minus 8, equals 4 times 2, that's 8 times x plus 1. So I just got rid of those denominators, just makes things simpler typically. Now I'm going to distribute on both sides. So 9 times x is 9x. 9 times negative 8 is minus 72. On the right, when I distribute, 8 times x is 8x. 8 times 1 is plus 8. And now I'm going to choose to move my x's over here because I have the larger coefficient over there. So I'm going to subtract 8x from both sides. Get x minus 72 equals the 8x's cancel are 8. I'm going to go up here. And I'll just rewrite that. And now I just need to get rid of this minus 72 because it worked out that I just have 1x. I get 8 plus 72, and this gives me x equals 80. Again, you can check this. I think this is going to get a little more complicated. some of these checks, to be honest, I would just do on a calculator. So let's work through this and we can see sort of how the calculator would work. So on the left-hand side, I get 3 times 80 minus 8 over 4. Now let's go up here, 3 times 72 over 4. Now what I'm going to recognize here is this 72. This might be a little hard to see, but that's 4 times 18. Well, then the 4's cancel, and 18 times 3, that's 54. So again, the numbers are getting maybe not quite as comfortable, but in principle, this works out. The right-hand side is 2 times x is 80 plus 1 over 3. So this is 2 times 81 over 3. 81 is 3 times 27. Again, maybe a little bit hard to see at this point. 3's cancel. 2 times 27 does give you 54. That checks. So something I'd think about doing instead here is opening up calculator. So this is a graphing calculator here. Let's just, whoops, sorry. Doing something else earlier, so I'm going to just clear that out. And let's just get rid of that there. So on the left-hand side, the calculator knows order of operation. So I can just put this expression in the calculator. So that's 3 times, in parentheses, 80 minus 8, close my parentheses, and then I divide by the 4. So I mean, technically maybe I should have parentheses around the top, but it won't matter because of order of operation. So the calculator looks at it and says, oh, that's 54, and avoids you having to do this. On the right-hand side, I get 2 times, parentheses, 80, that's my x, plus 1, and then I divide by 3. So for our class, you can't really use your calculator to solve these, but to check, I mean, you could just do this on your own, to be honest, and not even write it down. Although it's, you know, just want to make sure you get the same thing on both sides. Okay. Next one. This one, we've got x in 3 places. So I'm going to use the same kind of strategy I've been using, where I'm going to simplify the left-hand side of the equals, simplify the right-hand side of the equals. So I'm going to distribute the 7. 7 times x plus 7 times 4 gives me 28. On the right, I'm going to distribute this 5. 5 times x is 5x. 5 times 2, that gives me a plus 10. And I'm going to distribute the 2, but I'm actually going to distribute the negative. So it's really a plus negative 2 times this. So I'm distributing the negative. Negative 2 times x is negative 2x. And then the negative 2 times 9 is negative 18. All right. Now what I'm going to do is I need to simplify this right-hand side down further. I'm just going to keep the left the way it is. And then 5x minus 2x, that's 5 minus 2 is 3x. 10 minus 18 is negative 8. Now I want to move my x's to one side or the other. I'm going to choose to subtract the 3x because the 7x is a bigger coefficient. So I'll get a minus 3x. Again, that's a preference thing, which way I want to go. I prefer not to deal with negatives if I can avoid doing so. 7x minus 3x is 4x. Still have the plus 28 equals negative 8. Now I'm going to subtract the 28 from both sides. And I get 4x equals negative 8 minus 28 is negative 36. And then I divide by the 4, and I get x equals negative 9. So there's my answer there. And now the check, now I'm just going to use my calculator. So I can do 7 times x is negative 9. Note I can't hit the minus, it has to be the negative 9 on this particular calculator. Plus 4. So my left-hand side gives me negative 35. Is that correct? Well, I don't know until I evaluate the right-hand side. So this is 5 times negative 9 plus 2 minus 2 times, well, this is silly, negative 9 plus 9. Negative 9 plus 9 is going to be 0, so you could really leave that off here. But the calculator gets negative 35. So this one you probably could have done by hand. But the point is, I don't really need to show that work. I just want to figure out, you know, hey, these two things are actually equal. Okay. Next one. Very similar question. Note here, it's almost the same, just that this plus changed to a minus. So let's see what that does to things. So what I'm going to get is distribute the left hand side. 7 times x plus 7 times 4 is 28. 5 times x is 5x. 5 times 2 is plus 10. Negative 2 times x is minus 2x. Whoops, hitting something to make that come up. And negative 2 times negative 9 is a positive 18. So it's the negative times the negative is a positive 18. Now what I'm going to get, let's see, 7x plus 28 equals 5x minus 2x is 3x. 10x plus 18 is plus 28. I'm going to subtract the 3x. Here, you may have noticed we got 28 in two places. We'll deal with that in a bit. 4x plus 28 equals 28. And now I'm going to subtract the 28 from both sides. That gives me 4x equals, well, 28 minus 28, that's 0. So sometimes this confuses students when you get the 0. We really just keep doing what we've done before. I'm going to divide both sides by 4. The 4's cancel. X equals 0 over anything, well, anything other than 0 is 0. So my answer here is x equals 0. So now this one on the check, it's such an easy number to plug in, I'm going to avoid the calculator. It might be simpler to do on my own. So let's just do the left-hand side. Is 7 times 0 plus 4. Well, that's 7 times 4. That equals 28. Pretty much do that in your head once you get used to it. Right-hand side is 5 times 0 plus 2 minus 2 times 0 minus 9. So that's 5 times 2 minus 2 times negative 9. That's 10. Negative 2 times negative 9 is plus 18. That gives me my 28 as well. So our answer does check out. When you get a nice number like 0, it might be easier just to do that check by hand than to plug in the calculator, to be honest. Because you might even mess up plugging something in the calculator. Although if both sides were different, you'd probably look at what you entered a little quicker, or for a little bit. Okay, next one. We've got 3 times x plus 3 equals 2 times x minus 4. Same strategy. I'm going to distribute the 3. So I get 3 times x plus 3 times 3 is 9. And I get 2 times x is 2x. Minus 2 times 4 is minus 8. Note I have one negative here, don't have one there, so the whole thing is negative 2 times 4, or negative 8, or subtract 8. Now I'm going to move the 2x to the other side, because 3 is bigger than 2. So I'm going to move toward the bigger coefficient on x. And I get x plus 9 equals negative 8. And I'm going to subtract 9 from both sides to isolate the x. And I end up with x equals negative 17. So to check this, say it's 3 times negative 17 plus 3 gives me a negative 42. And 2 times negative 17 minus 4. Might be good practice to go through this for the arithmetic, but a quick check like in an exam. Whoops, I didn't really talk about what happened there. So you got negative 42 for both left and right. That means sort of my answer checked out. Okay, next one. Okay, we got decimals here. So what do we do with decimals? Well, my general policy is to try and just get rid of them right away. So what I'm going to do is I notice there's one digit to the right of the decimal point in this term, one digit to the right of the decimal point in this term. So I'm going to multiply both sides by 10 right away. Note, I'm going to use these square brackets because there's parentheses here already. So before I do anything, I'm going to multiply the left-hand side by 10, but then I have to multiply the right-hand side by 10 as well. And then this 10 will distribute 10 times 0.4x minus 10 times 0.1 times x minus 100. 10 times 70 is 700. I just tack a 0 onto 70. Now, 10 times 0.4, I move this decimal point over. I get 4x. 10 times 0.1, well, that's just 1. Don't really need to write that, but you can. Equals 700, and now I need to work on this left-hand side. So I got rid of the decimal, and that was really my goal. So this is 4x minus 1 times x is minus x. Minus 1 times a negative 100 gives me positive 100. Negative times a negative, effectively. And so I get 4x minus x is 3x. Plus 100 is 700. And now I subtract 100 from both sides. And I get 3x equals 600. And kind of run out of room, so let's go up here. I have 3x equals 600. And then I divide both sides by 3. 3's cancel on the left. 6 divided by 3 is 2, and I end up with 200. So that's my answer. And I could check this. The decimals, it gets probably more simpler, or relatively simpler to check on the calculator here. So I get 0.4 times 200 minus 0.1 times 200 minus 100. Another 0 there. And what I get is 70, which is what I expect, so it did check out. Okay, another decimal question. I want to solve 0.06 times x plus 200 plus 0.1x equals 172. Same strategy as before, but now we have one decimal with 2 digits to the right, one with 1. So I'm going to multiply both sides by the larger, which is 100. If I multiply by 10, here I'll just get 0.6. So if I multiply by 100, I'll get rid of both decimals. So let's work this out. 0.06 times x plus 200 plus 0.1x. And then I need to multiply the right-hand side by 100 as well. And so I distribute that 100. Some of these steps here you'll start to skip here once you get used to them. And then the 100 times the 0.1x as well equals 100 times 172. I just tack on 2 zeros. That's 17,200. Now 100 times 0.06. I move my decimal point 2 spots. That's 6 times x plus 200. 100 times 0.1. I move my decimal point 2 spots, but that means I have to add a 0. And so I get plus 10x. Okay, now I can simplify the left-hand side and just sort of treat this like a normal problem. Some biggish numbers, but hopefully those will simplify out. Distribute the 6, we get 6x. 6 times 200 is 1,200. That equals 17,200. 10x plus 6x is 16x plus 1,200 equals 17,200. Subtract the 1,200, and I get 16x equals, 0, 0, 2 minus 2 is 0, 7 minus 1 is 6. 16,000. And when you divide by 16, really these 16s cancel out basically on the left. Well, and then essentially I do on the right, but I'm left with 1,000. So that looked a little bit scary with the 17,200, but things worked out fine in the end. Then we can check this. 0.06 times x plus, whoops, I just wrote x, which you can do on this calculator, but I have to type in a value here. Otherwise, who knows what it's going to use for x. 1,000 plus 200 plus 0.1 times 1, 1, 2, 3. And that gives me the 172 that I was expecting, so this answer checks out. Okay, so that ends our worksheet.